Good afternoon, everybody. Welcome to our presentation. It's called Exploiting Hotel Cassandra. Before we continue with the presentation itself, we get the question a lot. How did you come up with the name Exploiting Hotel Cassandra? Obviously, because it describes our presentation. But we just want to give you a little bit of insights how we came to this name. Our talk is going to be about a multi-tenant solution within an enterprise like ING. So when we started to explain the multi-tenancy, hotel came to mind a lot, also to other people. So Hotel Cassandra was born. And actually we're now presenting in California. So we just heard a song, Hotel California, you might have recognized it. And we started to look at the lyrics. And the lyrics actually explained very nicely some journey that you can go through in life, but maybe also in business. And in this case, it was business. We actually could match the lyrics of the song quite nicely to the journey that we went through at ING to implement Cassandra. So we're using the lyrics a bit throughout the presentation to explain how our journey is and how we experienced Cassandra within ING. For those who might not know ING, we have a short video to introduce ING, which I want to show first.
All around us, our world is being reimagined.
Here will be the house.
Some see possibilities.
Make it happen.
Others are feeling the pressure. We're starting out and starting over, making changes, connecting. It's quite a time to be alive. Our customers are on the move, taking small steps,
There's your wind turbine.
dreaming big dreams.
I'm going to own that house someday.
They're not thinking about us.
Oh, you're so cute.
They're thinking about possibilities. We're not here to change them. We're here to salute them. To help them forge a better tomorrow through the choices they make today. So to the builders and the makers, the explorers and pioneers, the lovers and the fighters, to the inventors and entrepreneurs, the movers and the shakers. To all, we declare our commitment to empower them to stay a step ahead in life and in business.
Let's get on board.
We really like this video, and ING is really in the business of empowering people to stay a step ahead in business and in life. And we also feel that for the employees. Just a short recap of ING. We are based in over 40 countries, so we're an international player, and we have about 52,000 plus employees. We're predominantly in the commercial banking, but if you look into the European market, we then have more of a challengers and retail banking. If you have a look at the Netherlands, we are the largest bank, and we are a full-service bank. So one of the challenges we have at ING is that we have to supply all products and services for customers. And that actually means that we also have 150 DevOps teams within retail banking alone. We also have commercial banking and group services. So as an organization, we're really dealing with a lot of teams. A little bit about us. My name is Stewart. I'm an engineer and an architect. I gave a talk last year and I announced that I have a love-hate relationship with Cassandra. That's still true. It really forces you to think in a different way, and you really do have to solve problems differently, to put it that way. About 2 years ago, Chris and I worked quite intensely, and we were fortunate to get onto the Cassandra bandwagon.
Yes, that was quite a journey already. And so we started off working on Cassandra, which was very cool because we both are more the back-end guys than the front-end guys, if you really ask it from us. Next to that, there's also, we are adopting the Spotify way of working within ING. So we also define some chapters, and one of those chapters is the distributed data chapter. So the distributed data chapter is responsible for actually the development and the maintenance of our Cassandra within ING itself. For the Netherlands, I'm the chapter lead of the distributed data chapter as well. So that is also where our connection with Cassandra comes from, and why we are still working quite intensively with Cassandra within ING. So we introduced ourselves now, we introduced ING, and now we want to take you back 2 years ago when this journey started at ING. So we really felt like we were on a dark desert highway. We didn't see the end of the road, but we did know that the road around us, or the scenery around us, was changing. The customers were getting new expectations, different expectations from companies. Not only financial institutions, all the companies around us. Why? Because we are more and more becoming an always-on environment. Everybody around us expects everything to be always on. So they expect availability, always. And not only availability during office hours, but also availability 24/7. We're no longer only sticking to our own countries, we're also going global as people. So that means that we also saw that people were traveling a lot and they also wanted to have access to our data when they are, for instance, in California like we are. We also want to see what our balance is on our accounts, even though we are here in California, of course. So 24/7 was becoming more and more important, also for financial institutions. And consistency. Consistency was always important, but there is a new dynamics in there, to say it like that. We are an omni-channel bank, and if you want to explain omni-channel, you can explain it partially by saying we offer multiple channels to our customers. And what are those multiple channels? Well, I'll give you 3 examples, or actually 4. The first one is mobile. The second one is My ING banking, so that's internet banking. And we also have assisted channels called the call centers and the sales offices, so the branch offices. So they are all channels to our customers, and they all expect the same information coming back from all those channels. So there's no longer only a consistency within the channel expected by our customers, but also across the channels. They hop the channels. So that pretty much means once they have opened an account in the store, in the branch office, and they walk out and they log on to their mobile device, they better yet see that account and they better yet see the balance and they want to start transferring money. So that's very important. That's also changing. That was changing around us as well. And in order to make all of this possible, so all of those devices that we're seeing, not only mobile devices, tablets, even watches nowadays, they connect to our systems. So that means that there's a lot of throughput coming on our systems and also a lot of demand coming on our systems. So that means that we needed to be more scalable than we ever were before. We need to be fast and easy scalable as a bank within our, for our applications as well. So those were the external challenges we saw. So the world around us was changing, but also the world inside of ING was changing a bit. And what was changing, or it's not really changing, but it was more like a challenge that we saw when we started with a technology like Cassandra. And then we're looking at lots of small use cases. Gary already introduced the 150+ DevOps teams that we have in domestic banking alone. So that means that they're also working on use cases. But they are relatively small use cases if you compare them to other use cases for Cassandra. So it's low TPS, low data footprint. So they don't really deserve, or maybe that's the wrong word, but it is not cost efficient to have a cluster per small use case in this sense. So we needed to start doing something about that one. The other one that was happening is we were going to Sun. So you might have heard it a couple of times already today, I guess. Sun is sort of an anti-pattern when you start using Cassandra. If you didn't hear it, well, then this is the first time you hear it. Don't use Sun, because that is not anywhere recommended when you start using Cassandra. So we needed ephemeral storage, dedicated storage on our machines. So that was another thing that was changing already in the bank, which we have to countermeasure in that sense. And the last one is most actually visible when we started the journey was there was 0 to none NoSQL experience. So we really needed to do something about that one. Not only within the bank, but also within the Netherlands itself. It was a niche expertise. So actually I liked what Billy Bosworth was saying during the keynote this morning. He said, if I look 2 years back, Cassandra was, well, not that known, but it's exponentially growth like the last 2 years. And we saw the same thing happening in the Netherlands. The Cassandra meetup in the Netherlands had 115 or something users, active users within the Netherlands when we started off. It's now growing to 500, 600, and each year, each month, each day, we are still getting new experts on Cassandra within the Netherlands as well. So that is a very nice thing for us, because that means that the pool of people is growing as well.
Absolutely. But you know, when we started this journey, to change to distributed and to change to NoSQL, we felt like it was could be heaven or could be hell. It's not working. There we are. So we really started with a POC, and we did a lot of use cases, and we did testing, and we did all the things that Patrick McFadden just spoke about in his talk previously. And we learned a lot. We really learned a lot. We stretched our comfort zone, and basically we came to the conclusion that Cassandra will probably be the solution. Why? If you look at Cassandra compared to other NoSQL products, you have CQL. CQL is familiar, so it brings that familiarity back to the developers. They're already familiar with SQL, so they don't have to learn a new language. But I think the other differentiating factor for Cassandra is its masterless architecture. When you have a masterless architecture in the start, it's actually very difficult. And by being sort of spending the time on the attention to detail at that, early on, you get the benefits later. But I think the killer feature is active-active over data centers. Chris mentioned earlier we want to be always on architecture. So we can't do upgrades without having an active-active architecture. So we started realizing Cassandra is the way to go. And we did a really intensive proof of concept. I think it was about 4 months. I think we walked into every wall. Because it was a critical process, we paid attention to the details. And it was through that process that we really learned how to use Cassandra and what it actually means. But it brought us into a sort of feeling of, are we ING ready for it? Because remember, we're a small team and we've got a large organization behind us. We've had the period to embrace and adopt the technology, but everyone else needs to have the time to do that because it's a different way of thinking. Fortunately, something else is happening in parallel. And something else is happening in parallel. And we realized that this movement, RESTful APIs and Cassandra fit in quite nicely. Because when you have a look at APIs and RESTful services, you tend to have a resource, and in this example we have a customer resource, and you tend to have an ID, and that will be your petition key. So customer could be your table, your ID could be your petition key, and then you can have your data. So for us, we started realizing APIs also force you to think inside out, top down, so you have to know your queries first. And if you know NoSQL and Cassandra, you really need to know your queries, not your entities, not your relationships. You need to think top down. So it was this movement that got us, how can I put it, an accidental success that it was happening at the same time. The opposite is not true, by the way. A Cassandra table doesn't necessarily make a good API, because remember, your APIs cover your technical details under the hood. But if you realize that you're going to have a lot of APIs, so this was something that we were starting to get worried about, because we need to combine all these use cases. And this is why we came up with a Hotel Cassandra, because we really needed to put them together. And as Chris was mentioning earlier, it's all about the efficiency of costs. Because in the end, if you have a cluster per use case or per API, imagine going to microservices, then it's going to get really crazy on the costs. And I know we're a bank, we might be made of money, but we also have to be careful. So the other paradigm shift is that we're comfortable with sharing on the hardware level. So we're all going to cloud, we're all going to SAN, but now we're asking people to share on the software level. And this is, again, something that people get nervous. So the question is, do we dare to share?
And we do. We strongly believe we do. But in order to be that certain of our case, we had the visualization session with the team. And within the output of the visualization session is the picture that we're showing here. And it's actually sort of a touch point, not an architecture, but it's a touch point picture of what our vision was and what our touch points were that we needed to work around or work at to make sure that we get the customer experience that we want from a Keyspace as a service solution that we are offering. So we are offering a luxury hotel to our customers, and they have expectations. They have high expectations of this. We already mentioned in the beginning of this presentation that the experience and the knowledge on Cassandra was very niche in ING and in the Netherlands itself. So training is key. But it was sort of an accidental success. We also learned a lot from giving the training ourselves. So we started giving the training. We started to get to know the other developers within the company. And we learned a lot from the use cases that they brought to the table during those training. Because they wanted to know what was happening. How can I implement my use case? And they really liked the fact that we were actually developers as well, not just trainers. That we also had our foot in the mud, just to say it like that. Not sure if it's a proper English expression, but it is Dutch. So we learned a lot from giving a training, and the feedback moment was already started from the training on. Next to that, we are a big company. We are a corporate, we are an enterprise. So that means we have a lot of procedures. We have paperwork that we need to go through before we can put something in production, right? I think most of you might recognize that. Next to that, we're also a financial institution, so we have compliance rules, which adds some more documentation and procedures. So that is tedious work, especially for developers. Developers like to code, right? They like to build, they like to design, they like to make stuff and make it happen. And they don't want to spend much time on the procedures and the documentation normally. So we wanted to take that big chunk of tedious work, that paperwork away. That is a promise that we gave from the get-go. If you take a Keyspace from us, we will reduce your paperwork. Well, that could be great, right? So that's what we did. And in order to do that, we needed to take a big chunk of their responsibilities away, or their ownership away. And that is the unexpected load and the infrastructure. Those come together very intensely. So we will service the infrastructure. We will make sure it is there. We will make sure that the Cassandra stack is there. And when you need to grow, it will grow automatically for you. We will make sure it happens. So that's already a lot of paperwork less for them. They only needed to do the little paperwork that is needed for the Keyspace itself and their application, which they already needed to do anyways. Next to that, we also had something called functionality. Well, we know the DataStax driver. It got introduced a couple of times already today. We built a thin layer around it. Why? Because of those compliance rules again. We don't want every team to build those compliance rules over and over and over again for connecting to Cassandra. So we built a thin layer around it just to supply this to them and make sure that they could use it. So when they start using this in their applications, they also got something which we call governance, so the driver governance. And that's pretty much based on metrics, but Gary will touch it later on in the presentation. And that gives us lifecycle management. So based on that, we know what is happening with the drivers. We know the version of our clusters within ING. We know all the client driver versions as well. So we know when we can do upgrades on our clusters as well. Not everything is backwards compatible or forwards compatible within DataStax. So that is already key. And we had this feedback moment going on from the beginning, as I said. But next to that, we also assigned a dedicated person to the teams to have this feedback loop going on constantly and learn from them and make sure that customer expectations are met.
Absolutely, and we had to take it one step further because in the end you need to experiment. So we basically came up with a sandbox environment. And by having a sandbox environment, active over data centers available for teams to test their use cases directly. Because if you realize, it's a distributed system. So you can do your unit test, you can test everything on a single instance. It'll work. It almost always works. But it's when you go active over data centers and then you start testing your actual use case and the behavior, then you start learning, and that was what we needed to do for the company. So by having a sandbox, we enabled teams to fail fast or succeed fast. And it's that real sort of mentality that will, how can you put it, enable a smoother feedback cycle. Because remember, it's about sharing in a company as well. We don't always have all the answers, and we don't know all the use cases that are there. So if you create a sandbox, active with your infrastructure, then you enable teams to, well, test themselves, and then also maybe teach you. But the other challenge we gave was, we said to them, do what you think is right. We want to see the containment issues. We want to see what teams can do to hurt the cluster.
Yeah, definitely, and they did. So that is very successful communication from our side. So we learned a lot on the sandbox environment already. We saw that there can be a lot of containment issues, and we definitely didn't want to go that one onto the production environments as well. So we wanted to go and see how can we fix these containment issues. Can we fix them either way? So that's the question actually. We know we can do it with hardware. We already mentioned it before. That's what a lot of people are doing, or a lot of companies are doing. But that was not cost effective for us as enterprise, since we have those small use cases that I was talking about at the beginning of this presentation. So hardware was not the option for us. Then we looked at Cassandra. Can Cassandra offer containment on Keyspace level? It can on Cassandra level, on JVM level, on process level. It can definitely give you containment. But on the Keyspace level, Cassandra doesn't give you containment yet. Might in the future, but at this moment of time, on Keyspace level, there's no containment. So we needed to go look further. And then we looked into new other technologies, like next to Cassandra. Then we're thinking about container-like technologies. We know Docker, we know Mesos. And they look very promising, but we didn't have that skill in-house yet. So we couldn't actually use that at that moment of time to make it work for ING at that moment. We are still looking into it, and we are planning to start incorporating it more and more for our containment. But for now, we had to stick to what we have. And what that is, we got our software and we have our teams, our people. So that combination, that strong combination is needed to get proper containment on your key spaces. But in order to make sure that everybody feels the ownership, you need to make some stuff visible to them. You need to give them insight on what is actually happening. So we adopted a spider graph. And a spider graph is pretty much what you're seeing here. So we defined a couple of points on the axis, which we think is important when you start using a distributed system or when you start using Cassandra. So some examples are consistency. Read pod, write pod. Is it write heavy? Is it read heavy? So we started putting patterns on our clusters based on what we want to do with the cluster itself. So based on the cluster pattern, you can also match use case patterns on there. Because you can do the same type of scoring on a use case, and then based on the scoring you're doing on the use case, you can map it on the clusters that you have. And when you have a good fit, you can say, okay, you can go to this cluster. It's perfectly tuned for your use case. So we are actually tuning the use cases based on the information that we want to, or on the axis that we are showing in this specific spider graph. This is a cache use case, so that is very important to have consistency. Why is consistency so important? Because it's a cache layer. So when we store something in the backends, the system of records, it better yet also be available in the cache layer as well. So consistency is very important for this use case as from the beginning always onwards. Also the fall true. So we need to be sure that it can handle faults easily, because we have the most containment issues going on these kind of clusters, because we have a lot of cache use cases within ING itself. So those are just some examples of points that we can stress on to see if we can match some clusters and some use cases on top of each other.
Just to add to that, the point is when you are on the zero, then it's cheap or it's less complex. And as you go to the outside of the spider graph, it becomes more complex, more expensive, and more challenging. So this is the way that we were bringing it to the teams to understand how complex or simple each of the aspects were. And in contrast to this example, we have another example. And this one is, for example, a fraud detection use case. So what is the particular footprint of that one is we need to save all the events. So every time the customer is doing something, we'll save all that information. And when we suspect something going wrong or an incident, then we need to read. So you can imagine very heavy writes and very, very few reads. So that's why you can see we needed to be tuned for the writes, and the reads are not that, say, important. But if you can start seeing, now we have use cases and clusters being matched together. This also allows us to match that to the configuration. And it's by matching that to the configuration that you can then tune your cluster correctly. But we also came up with something else. And not work yet. We started a project called the Hubble Project. And basically what the Hubble Project is, it uses the Confluence API. If you're not familiar with Confluence, Confluence is a collaborative documentation platform. Why we like Confluence is because we already had it, and it's integrated into LDAP, so we have all the security and access on it. But there's two really nice features, and the one feature is versioning. So as you edit your page, you can actually see in time what the previous versions were if you want, and you can compare different versions. And the second feature is notifications. So if you make an edit on a page, then anyone watching that page can get a notification of that change. So if you use Confluence and then you say generate your data models, then anyone interested in that schema will get a notification. You also then get versioning of your data model over time. So we wrote a program in Scala, and we basically use the DataStax drivers, and they have a class called the metadata. And if you use the metadata, then you pretty much get all the schema information, all the configuration, and then you can actually use that to, say, generate your documentation. We'll show you a couple of screenshots on what that looks like. So now you can see a sort of loop where a developer deploys a model into the cluster, and then we will generate documentation. But this wasn't good enough for us. We needed to take it one step further, and that was starting to add the operational side of stuff. So if you take OpCenter, so that's a tool from DataStax, where you get all your metrics and information. The nice thing about OpCenter is it also has an API, so all the information that you see there is exposed through APIs. If you configure your clusters to use proper naming conventions and you push all your metrics to Graphite, then you can use the Graphite APIs to extract your information. But this is only half the story, because we don't per se care about the cluster. In the end, our customers are the applications. So we needed to know how the applications are responding to, or how is their customer experience. So earlier on, Chris mentioned about the DataStax driver and the thin layer we put around it. That's one of the examples is naming conventions for the metrics that the application should push out. Why? Because you don't want to overwrite your metrics, and you do want to find all the applications that are running on that cluster. So if you follow good naming conventions, then you'll be able to use the APIs to find your information. So now we can actually use the Graphite. We've got OpCenter, and we're able to generate interesting web pages for the DevOps teams. But we're a bank, so we have one extra problem. We need security. And sort of, again, a bit of an accident, we realized that we're almost halfway there. So if we create a continuous delivery flow where we get teams to put their model into Git, and then we deploy it via Jenkins, then the DevOps teams don't need access to the cluster. But because we have the Hubble Project, and because we're generating the Confluence pages, and because they get notified of the changes, we've completed the feedback loop. So they don't feel that they're blind on what's happening in the cluster. They're getting the information they need, but they don't need to be in the cluster. So this way, we can actually give the information to the teams and complete the feedback loop, because in the end, we're mixing use cases, so we're mixing data into the cluster, and for a bank, that's a big sort of thing, so we really want to make sure that we don't get anyone into the clusters.
No. And Gary already mentioned those Confluence pages that we are generating. We want to give you some examples and how it gives the other DevOps teams more insights, so the operators and the developers of the other teams, how it can give them more insights. And we want to start off with insight on the Keyspace. And we already introduced the sandbox environment, but we also have a dev, test, acceptance and production environment at ING. So more or less a standard DTAP street implemented at ING for everything. So also for our clusters. So in a sense, one cluster for us are 5 clusters in the end, because we have to maintain all 5 clusters on all 5 environments. But the same goes for the Keyspace for all the other teams. They also need to know what their Keyspace is doing across all those environments, and preferably in one view. So we are, in this sense, giving them the overview of what is happening with their Keyspace across all those environments. Green in this picture means there is a Keyspace, your Keyspace is in that environment, and red means it's not there, pretty much so. The other one we have there is the number of tables. And that's there just to show you if there is any difference in the model based on the tables that is there. It doesn't necessarily mean if you have a different amount of tables per environment that it's wrong. It can be right for your specific use case, of course. But it can already, if you don't expect it to be different, you get all the insights based on this specific page that we are offering to you. So that is the key spaces. But the other one that is very important in a distributed system are the nodes themselves. And the Cassandra YAML is most likely the most important configuration file there is in Cassandra. And that's also where you can do the most tuning on the Cassandra specific level, let's say it like that. So we want to show them the actual Cassandra YAML configuration per node. This is just a snippet, of course, because it's a much larger file normally. But it can already show if there is a difference in configuration per node, per environment. So that is already very interesting to give back to the operators and developers themselves without having to log on to the systems because they're not allowed to. So that's why we need this. We need to show this to them so that we can have zero touch on our systems below them. That's the whole idea behind it. So this is just some tuning settings, but they can also give us feedback on what they're seeing. So if they think we tuned the cluster incorrectly, we can change it, and most likely it will be beneficial for all the other key spaces of the cluster as well. So it's really going to distributed support. We are enabling distributed support just by having these pages as well, we believe. So another thing we want to touch upon is the amount of tables and the size of tables. That is very important based on your data model as well. You want to give this insight because it might be that your data model is using the wrong partitions. And in this specific example, we see that the min size of a node in the max size of a node have a relatively large difference between them. So that could mean that you're using a wrong partition key or a wrong clustering key in your data model. So that is already giving back the feedback, okay, your distribution of partitions for your specific key space is not really working out. So maybe we should do something about it. Maybe we can help you and change your data model or tune your data model so that it will be better in the future. So this is also giving insights for both the DevOps teams and also us itself. Coming back to those cluster patterns that we touched upon before, I want to go very quickly to this slide. But Gary already mentioned we can do software configuration based on those patterns, but we can also do hardware configurations. And for this one, we already explained the left one. And the only thing I want to say about that one is we are using SSDs. This is a cluster which can have typical containment issues. And last year's summit, we actually heard during a training, you cannot badly configure an SSD cluster. So go figure, we could use SSDs to prevent a lot of containment issues already from the get-go. But also we want to enable Solar and Spark. And especially for Solar, you cannot go with spinning disks. You need SSDs. So we need to be prepared for the Solar feature that we want to enable on this cluster as well. Going back to the fraud detection one, that's an interesting one. We're going to exceed the recommended max size of terabytes per node. We're going to 10 to 15 terabytes per node, where the max recommended is 5 terabytes per node. Why? Cost effective. We want to have as little nodes as possible, but with the right amount of data footprint that is needed for the use case itself. And we believe that data compaction can help here. We have a very nice introduction by Jonathan Ellis this morning as well. But we also need to do some tuning on our data model, of course. So we have to block it off as a table per month, for instance, so that we only have compaction going on for one active table at a time. The middle one is about high consistent use cases. That's actually the talk that we did last year. So for that one specifically, we introduced the third data center. We need 3 data centers for high consistent use cases. So that's just some of the things that we can match on those cluster patterns that we have defined within ING.
Yes, and of course, you know, one of the things that we keep trying to get to the teams is that it's a total stack solution. So we've now been talking again about the operations. We need to bring the developer side of it again. So earlier on I mentioned that we document the data model, because what we say to the teams is they have to own their own device. They know their data models. We can help them, but they know their own data model. They know the partition size. They know what data is going to be there. So if you see on this page that we're generating, basically we're generating the documentation for them, because one thing I've had a history of is documenting data models and then doing the data model and then get out of sync. So we decided we're not going to document data models anymore, we're just going to create it and we'll generate the documentation. And if you put your comments in to the CQL, then it will show up on the page. So if you have a look at the queries that were there, we also generate the default queries, because one thing we noticed is that teams tend to use other queries. So we say if you use these default queries, then generally speaking, you're doing something right. And as the song goes, they stab it with their steely knives. So we realized that teams are making the same mistakes as we did. And we spend a lot of time on the simple mistakes. So if we can get rid of the simple mistakes, then we can prevent a lot of rework. So part of the project, we also look for, say, overuse of indexes, or say incorrect data center names, or single column tables. So just the sort of simple mistakes, so then we get a feeling, do they understand Cassandra or not? So the more errors we have per, say, team, the more we realize, okay, we need to spend some time with them, see if we can get their knowledge up, figure out what we can do to help them. Because we want to spend time on the difficult problems. We need to free up all the time to not do all the simple mistakes. And then, of course, we'll aggregate it per cluster, and then we'll get a feeling on how many, say, good or bad tenants there are on that cluster.
Yes, and these are just some features that we showed in the page form. We have some more features in there, and we also want to add some more features to it as well. Maybe you guys can help us, because it is open sourced. But it is the tracking of queries. So we already do checks on the data model itself, but you can also make a lot of mistakes in your queries on the cluster or in your key space. So based on the actual queries that are happening on your key space, we can make best practices on them as well. For instance, partition scans, table scans, the basic mistakes everyone makes when they start using Cassandra pretty much. So we can already give back, okay, based on the queries that we see happening, you should be changing some of your queries, because we think you are experiencing slow queries or irregular queries based on what you're doing. Next to that, we also want to show and visualize the actual use case pattern. So we defined one at the beginning of the project, but once it is in production, we want to see what your actual use case pattern is. And if it still matches the cluster pattern that we have defined for this specific cluster. If it doesn't match, you might need to move to another cluster. Or we need to create a whole new cluster for you and tune it specifically for those kind of use cases. So we can also do a sort of machine learning on that one. And we already mentioned the data model check, 5 tables, but we also want to do it on the schema itself. And capacity management with prediction, because that is pretty much where we see the most possible containment issues with a Keyspace as a service solution that we are offering at this moment.
And to finish off, as the song goes, where we are today, you have to realize in the end, there is a need for availability, there is a need for scalability, and there is a need for unexpected load. So as the song goes, you can check out at any time, but you can never leave. Thank you.